Alright, from Tuesday's classwork, we started off with this problem, where we were told we had a given number of cards with different symbols, and we said event B is black symbol, event F is card has a 5. Let's jump down to the end. It says, are the events B and F independent? As soon as we read that, we want to go ahead and think about the overall probability as compared to the conditional probability. So the overall probability of the event that we pull a card with a black symbol, we are going to look at all 6. So that's a probability out of 6. There's 1, 2, 3 of those. Okay, so that's 1/2. The next thing that we're going to look at is a black card given that it has a 5 on it. Well, let's choose a different color for that. Let's do gray this time. So now all I'm looking at, given that it has a 5, all I'm looking at are the 2 cards with a 5 on them. Well, there's 2 of those. And only one of them has a black symbol. So that's 1/2. Oh, look, they're both 1/2. Yay, they both equal, so they are independent. Alright, same set of cards, but now we're looking at 2 different events. We want to know the probability of a black card and the probability of a card with an 8 on it. So let's do the probability of a black card given the probability, a black card given an 8. So the probability of a black card, that's still 3 out of 6, that's still 1/2. The probability that you have a black card given that the card has an 8 on it, well, narrowing it down to just 8, we see that both of those 2 cards have black symbols. Well, since 1/2 doesn't equal 1, that means no, they're not independent. Because probability of B did not equal the probability of B given E. Alright, so starting off with we'll do a Venn diagram for this one. Now, I know we went over this in class and we were talking about how we subtract, but we have this keyword only in here. So when we think about who's wearing, I should do it the other way. Who is wearing glasses, who has braces, we're told that 6 students have only glasses. So they don't have braces. 12 students have only braces. They don't have glasses. So this 6 does not include this area. This 12 does not include this area. There are 6 that have both. So that's going to make the Venn diagram look like this, with 6, 12, and then a 6 in the middle. So now when we're asking ourselves, what's the probability, are they independent? We want to go back to that. Does the probability of wearing glasses equal the probability of wearing glasses given you wear braces? Well, the probability of wearing glasses, if I count up everybody, there's 24 people altogether. So the probability that you wear glasses is 12 out of 24. The probability that you wear glasses given you have braces, well, that means we're going to look over here out of the braces circle. So there are 18 people who have braces. 6 of them have glasses. So 12 out of 24 and 6 out of 18. 6 out of 18. Well, those aren't equal, so no, not independent. And then constructing the two-way table from the information. This was kind of rough before our last quiz, so let's review that. So I've got this table, 2 columns and then totals, 2 rows and then totals. And we need to label these. Let's do, I can't remember how I did it on the answer key. Let's do cell phone, no cell phone. I did this the other way. Laptop, no laptop, sorry. Well, we're told that 78 people own a cell phone. So if I go down to the end of the row for cell phone, That means all of those people add up to 78. So that's 78 in a total column. And 57 of them own a laptop as well. So I'm going to put a 57 in the laptop column. When I do a little bit of subtraction, when I do 78 minus 57, I see that there are 21 people left who have a cell phone but don't have a laptop. Then let's look at the other information. I used this. 13 students do not own a cell phone, so that's this row here, the second row. Do not own a cell phone, but do own a laptop. Well, that goes in here. So 13 do not own a cell phone, but do own a laptop, sorry. And then, so we did that one. And then 9 students own neither. That goes right here. So then we can do a little bit of adding. 21 plus 9 is equal to 30. 57 plus 13 equals 70. So there's 100 altogether. 13 plus 9 equals 22. And these add up to 100, and these add up to 100, so we're good. So now we're just left to answer the question based on our two-way table. Are the events own a laptop and own a cell phone independent? So does P of L equal the probability of L given C? Well, the probability of owning a laptop is 70 over 100. The probability of owning a laptop given you own a cell phone, well, that's a different probability. That one's looking over here. We're narrowing it down to just cell phone users, which are 78, or cell phone owners, and 57 of them own a laptop. So do those two things equal each other? They're about 3% off, because 70 divided by 100 is 70%, and 57 divided by 78 is 73%. So no, they're not independent, but it's really close. Alright, that's it from Tuesday's classwork.